Hello everyone. Before I start talking about what I have planned for this video, I just want to mention a quick point. So I can actually run Python outside of this Python environment as well. So what I'm going to do is open my command prompt and I just need to enter the path to my Python directory and then say python.exe, and that actually gets me inside the Python environment and I can do things that we talked about last time. So I can do print hello and it prints hello without the quotes. And let me just quit out of this. I can also do something like write this path to python.exe and follow it with the path to a Python script. So at this very location I have our hello world.py script that we created last time. So if I go ahead and hit enter, it actually prints hello world. So that's how I can use Python outside of the Python environment. But for now, let's just go back to our Python environment. And what I want to talk about in this video are variables. So like we do in math, we can actually say something like x equals 25 and x would be a variable. So in computer science, what creating a variable means is that there would be a memory location which would be marked, which would be labeled x, and the value 25 would be stored at that memory location. So if I go ahead and hit enter, behind the scenes Python has stored uh, the value 25 at a memory location and given the name x to that memory location. So in computer science we have different data types. So just like in math we have integers, decimal point numbers, fractions, etc. We have different types in computer science. So like we talked about this type, uh, we talked about how this is a string, so that's a type. I can actually also do something like a equals hello. So the memory location named A will now contain the string hello inside of it. And some programming languages actually need you to give the type of variables. So the languages in which you would have to do something like int x equals 25, but Python doesn't require you to do that. And the fact that it doesn't ask for a data type for a variable means that Python is weakly typed. So languages which actually ask you to give types to variables are known as strongly typed languages. So what we can actually do here is we can find the type of variable that x is. So we can do type of x, and if we hit enter we get type int right here. Int stands for integer, so let's go ahead and also see type of a, and we get str, which stands for string. Let's now have x hold 2.5 and then do type of x again. This time it gives us the type float. So the word float actually stands for floating point decimal. So that's something that we use for decimal point numbers. Um, so this reminds me that last time we saw something like this, 5 by 2, and it actually gave us the result as 2. Um, the reason for that is because when we do operations where both the operands are integers, the result will also always be an integer. Um, what that means is that it actually does 5 by 2 and it is required to give us an integer as a result, so it just cuts out the 0.5 here. So let's see the result of 5.0 divided by 2, and this time we actually get 2.5. So what that means is that when we do arithmetic with floats, with one operand as a float and the other as an int. The result we get is a float. So one thing that you can try and remember for now is that something like an integer to float conversion is it's called a widening typecast. The word typecast stands for conversion from one type to another. So from int to float is called a widening typecast, and from something like a float to an int is called a narrowing typecast. So when we do operations with one operand wider in type than the other, we always get the result as the wider type, the larger type you might call. So that's it, I think, for this video. If you want, you can try things like, let's say we have x here, and let's say we create a y and give it 5. We can actually do x plus y, and that prints out the result as 7.5, which is as expected. And you can actually play around with it. And one thing that I'd like to mention before I finish off this video is that if you do something like 5 by 2 plus 7.0, let's say, so the result we might expect here is 9.5. But what happens, the result we expect is 9.5 because there's one float here and the rest are ints. But what actually happens is that because division has a higher priority than addition, it actually just does this division first. And as far as this division is concerned, both the operands are integers, so the result would be an integer, that would be 2, and that is what is going to be added to 7.0, and the result we'll get is 9.0 in this case. So the typecasting is actually done on a per operator basis. So for every operator, just look at the two operands for that operator and not the rest of the expression. So that's all for this video. I'll see you next time.